Hello everybody, with you Ismail from ctauthor.com. Today I'm going to talk to you about the article that I wrote for Linear Workflow. It's entitled Understanding Linear Workflow Working in Floating Point. And basically this video is going to be about sort of a walkthrough through the ideas that I mentioned in the article, and just to furthermore explain some of the key ideas. Okay? And also maybe to show you some practical stuff, visual aids, so that you won't forget some of the stuff mentioned. And also, to remove confusion. All right, so before we get started, I just want you to go ahead and read the article, okay? I'll go to this link and read the article because I want you to have some ground information so that we can be in the same page, right? So yeah, go ahead and if I were you, I would read it 3 times, take some notes, and yeah, so do that. All right, so I hope that you've read the article. I assume that you read the article. Now, let's go ahead and talk about the ideas mentioned here. So basically what I'm going to talk about in this video is linear workflow, color management, what it is, what value it brings to your workflow, and also, just to remove some kind of confusion about things. So linear workflow or color management because they're different, are the most confusing two subjects in CG world. I mean, a lot of people are struggling to understand this kind of workflow and implement it in their pipeline. What I want you to know is that, let's start with the bad news, and let's go to the good news after that, because the good news will be like all of the rest of the video. All right. So the bad news is we can't avoid this. Unfortunately, we can't avoid this. If you want neutral lighting, neutral shadows, neutral stuff in your scene, and basically there's no way to do it unless it's through linear workflow, really. Like if you want realistic scenes, realistic lighting, realistic colors, realistic textures, because the problem with non-linear workflow is that you get unrealistic result, dark scenes, blown out highlights, a lot of textures that doesn't match the original texture that you downloaded, right? Sometimes you're using a wood texture, for example, and I'm just going to show you an example here. So in this illustration, or this render, the texture right here is really dark, and we get clipping. What do we get as well? Especially after color operations, right? After you're doing curves and after you're doing levels in Photoshop. But here it's fine, even after doing a little bit of a color operation, really. So and here in this example we have the wood that matched the reference. This is really important. So this is why linear workflow is important. So basically we can't avoid this, right? I mean, we can't not consider color management in Gamma throughout the process of linear workflow. So Gamma is basically part of the linear workflow. Linear workflow is like the process, and Gamma is part of the process. It's part of the things that you should consider when doing your renderings, when you're doing your compositing, and when you're working with files out of, files, JPEGs basically, that has 2.2 gamma encode in it. So why linear workflow? Why non-linear workflow? Well, before we get started, I just want you to know something. Linear workflow means correct math. Okay, so basically to talk about math, let's talk about digital photography, and we're going to understand bit by bit this kind of thing. So I always go back to photography when it comes to 3D applications, as they operate the same. If you think about photography for a moment, photographers, for example, if you have a wedding photographer, prefer to work with RAW over JPEG because He rather preferred to work with RAW, then later on he can do post-production and have full control. Well, not full control, but anyways, sometimes they have to take two kind of ISO shots to really have the complete control after they're taking the shot. But just to really like give you the idea here, shooting in RAW will give them a chance to really not mess up, right? Because if they take in, they can't redo the wedding, right? Just to reshoot the photography. So basically, photographers prefer to have RAW in hand as a guarantee, if you like. So yeah, later on they can change, exposure, white balance, shadows, colors. They can even sharpen the image, even without destroying the kind of the details of the image. So they don't worry at all about losing data or getting blackness in their shot. So basically because they're using RAW, basically. And I'm going to give you just this example here. This is a shot that I took with a DSLR camera. Basically, I've configured the camera to shoot at once two versions. The first version is JPEG and the second version RAW, which is like the DNG, which is digital negative, right? It's like the old classic negative, but this one is digital. Anyways, I don't want to geek you out. So if you want to read about it, just look for digital negative in Wikipedia and they will give you a lot of information about it. But as you can see here, with this kind of range, we have much more detail here than this area. And the highlights are really different. I mean, you can see it. But it's kind of the same image. Now, what is going to happen if you apply one color operation to this? I'm going to go to Photoshop to show you. Let me just load the two files right here. All right. Okay. So this is the CRT and this is the JPEG, right? The CRT is basically the RAW file from the Canon. So basically, I'm going to apply a -4. Basically, this is not the original. I'm just going to copy this. I'm going to do a default because I've done it before when I was preparing for this tutorial. So basically, this is the CRT and this is the JPEG format. So I'm going to apply the -4 exposure and a -4 exposure right here. So what I've done is one color operation. So I want to see the difference. I'm going to zoom in here and I'm going to zoom right here. I'm just going to zoom right here and just to see the difference right here. We have a little bit of a detail here with the 12-bit, which is the RAW file. But with the JPEG, it's almost completely damaged, right? Let's go a little bit down here. Let's go to 5. Maybe I don't know, maybe 8. Okay, I can't go more than -5. Let's go with -5 here. Okay. So basically, you see the difference. I mean, this one is completely flat, right? If we look at this area compared to this area right here, I mean, here we can see a little bit of a detail with the 12-bit, but with the 8-bit, it's completely gone. Actually, we don't have the detail at all, right? And the same, it becomes really flat, and it's not as this one high dynamic, right? So it's a lot more range. And speaking of range, I'm just going to show you an example here, and why we have this kind of a result right here versus this kind of a result. Why this one is really blown out like so quickly, and why this one is really taking the time. I mean, even a -5, it's still here with the details and stuff. So the explanation for this is this kind of example here for the floating point. So this is a gradient non-linear, and this is a gradient linear, non-linear, linear. As you can see in the non-linear, the black goes to the white very, very, very quickly, and linear, the black goes to the white, but very slow, right? So if we open those two gradients in Photoshop, I'm just going to open it to show you. Okay, let's say that, for example, that this kind of this one correspond to this one. Okay, let's say that this area here correspond to this one. So basically, in the nonlinear, which is the one at the top, the gradient at the top, basically it's going very quickly to this kind of color, to this color. That's why actually when we use just -5 for the other example that I showed you earlier, it became it completely destroyed the details and it become flat and we get clipping. And for linear, basically, we have a lot more range, especially if it's 32-bit. Now, we have just 16-bit or 12-bit for the photography, but for 3D, we have 32-bit to work with. So basically, the range, as you can see here, and I'm not sure, I mean, just my eye, but anyways, I don't have microscopic eye, but basically, this one could correspond to this one, actually, not this one. So as you can see, we went to this color very slow. Like this one has to go like very quickly, like it went very quickly to this color at -5. That's why we get clipping, we get unrealistic results in 3D scenes and stuff. So the same thing happened in 3D applications in 3ds Max. It could be in Maya, Cinema 4D. It's the same thing. Okay, let's go back to the example here. I'm going to show you this example to furthermore understand this kind of effect. Basically, the kind of a gradient nonlinear, which is the first one, is basically this kind of range to work with. And I created this this cup test here, or this cup example, because this is how I see it in my head. Basically, in linear, I have this full kind of cup to work with. But in nonlinear, we have just this small range to work at, maybe less than that, I don't know. And yeah, this is tinted. Yeah. Okay, so here's another example. This is the original footage. And okay, so what I've done basically is that I created a 32-bit file out of this original footage, the JPEG, and I created another one with an 8-bit float, right? And basically. You can do that pretty easily, but just go in here. One second, I'm just going to delete those. When you create a new file, you can switch it to 32-bit or 8-bit. So what I've done is I created the first one with 32-bit and the second one with 8-bit, and I saved those two. Now this one I saved it as a TIFF, and this one as a 8-bit. But after one color operation, which is adding exposure, basically this one isn't clamping, but this one doing the same amount of exposure, it went clamping. And why? Well, because of the gradient that I showed you before. Now, it's not because of the gradient, it's just because of the principle of the gradient, right? I don't want to geek you out, so basically, just to really understand this, you have less range to work with here than versus this right here, okay? Okay, so now what next? Now we're going to talk about color mapping, which is really important in V-Ray. I want to get this out of my chest because I get this question so much from my friends, my colleagues. So what is color mapping basically? This is a quote from spot3d.com. Color mapping has the task of remapping the image value to be suitable for display purposes. Now, color mapping for me is a filter for a lens, for a DSLR, right, for a camera. And I'm gonna tell you why in just a moment. But basically, this is important. You can set everything to default in color mapping and you are done, since it's gonna change only the very bright areas to make it less bright by clamping the colors so that they don't exceed over bright values like 1, the case for exponential type, etc. So basically, if you're using a type of exponential, Reinhardt, etc., basically those are algorithms, or for me, as you know, they are actually filters or some kind of a mask that compensate the shot. It goes to the areas where it's over bright and it clamps it so that it doesn't exceed 1 value, right? So and you can really like have it less than 1 if you like, and it's going to be much more worse. It's going to be worse, right? Because it's going to be much more flatter and less details. It's going to be gray, right? Okay. Okay, so basically to go back to the example of the filters, I'm just going to show you here a video, and you're going to understand in a second. Let me just find the right frame here. It's around 6, right here. Yeah, right here. So basically, Dave How-To here, and thank you, Dave, for the example. Dave, if you listen to this video, thank you so much for the example. Sorry. So basically, Dave, what he was doing here is showing us how to compensate a scene. Basically, he's going to be sitting in this area. So he's using this avatar as an example to really compensate the shot. What he have now is a DSLR shooting this video with a 24 image per second, framing. Basically, 24 per second, basically, we have to choose double of the shutter speed. So basically, it's going to be 50. So he chose 50, and then he made the ISO to 100 so that he doesn't have noise in the shot. Now, the shot looks really okay. But now, he wants to change the aperture. Why? Because he wanted a little bit of a depth of field here, like a blurry effect, cinematic look in the background, but he's going to be in focus, so he's going to be sharp and clear. So basically, when he did that, he had kind of overexposed areas all over. So what is the solution? The solution, basically, he added kind of a filters to his shot, and this is kind of a glass that you add in top of the lens so that you get over compensation in your shot, right? So I'm just going to show you how he did it here. So 1 second. Voila. So he's actually placing kind of a filter just to compensate, and then he gets this kind of effect. So basically, he have the shallow effect, if you like, the film look at the background. He's not over bright. He's in focus, and he's using 100 as an ISO and shutter speed 50. So this is what color mapping does as well. So if we go back here to the examples, if you have color mapping and type as linear, you get this over bright in the windows. If you use the exponential type, basically it's a filter. And this filter is basically what it's going to do is it's going to analyze where there is overbright areas, and it's going to make it, compensate it and make it more appealing. So it's basically a choice. It's up to you. If you want this, do that. But basically this is going to clamp your output, and it's not good for compositing. The method that I use basically is this one, the linear. I let everything by default. I choose linear as a type for color mapping or tone mapping, and then later on in Photoshop or After Effects, Shake, Nuke, or whatever, you can change the tone mapping. Actually, there's kind of tools for that. And also, if you use multipass compositing, you have much more control than that. Actually, you don't care at all about those kind of overbright areas, actually, because you have the light pass as a separate pass. Sorry. So yeah, this is what it is. And don't worry at all about the settings. So this is the role of the filters, and it really is like the color mapping types. All right, so now what to do next? Now the question is, working in floating point, is it important? Well, I think you guys know. I mean, it is really, really important to work with the necessary range. And remember this cup example. I mean, linear gives you much more range, and non-linear gives you like this little range to work with. Okay. To sum up, I'm just going to show you this map, and it's basically the process, the whole process. So the idea here is in a model we have a linear space, which is basically your 3D application. It could be 3ds Max, it could be Maya, Cinema 4D, XSI, any kind of 3D application. It could even be Nuke. So basically we have files coming in to the application, to the 3D application, and we have to tell our 3D application in a way. It could be sitting, or it could be a node that you have to place, for example in Maya, or every application has a way. But anyways, you have to tell your application in a way that this kind of texture, hey, this kind of texture have a 2.2 gamma, so make sure to de-gamma it before you process your calculation inside of the rendering engine, right? So this is the idea. And then we have the EXR files that we're going to use, for example, in the sky dooms to really like illuminate the scene. So those are really with one. And if you are importing baked maps, for example, normal maps, etc., you have to override the value of that map to 1. And again, using the way of your 3D application. So every 3D application is really having its own way. All right. After we've done the rendering, so we are in the frame buffer now. We have done the render. Everything is okay. We have good lighting. We have good stuff. We don't care. We have everything done. Now we have two choices. Okay. So if we don't care at all about post-production, we're just gonna export, a PNG or a JPEG or whatever as an 8-bit for display. For the web, for TV, for Facebook or whatever. And then we have the second option, which is taking that full flow data that we have rendered right here as an EXR file. And I'm using EXR file because it's the one that really supports multipass compositing and stuff like that. It's really one of the standard files for full float. And basically I export that and I go to Nuke or After Effects or Shake or Photoshop, and I do post-production there. And then after I finish with this, and then I come back and I export the 8 bits, right? So basically you have two choices. But at the end of the day, when you export for the web, you're just going to export 8-bit even from Nuke after you've done the compositing here with the EXR file, full float. Okay. So this really sums up. I'm just going to show you 1 second. I'm just going to show you another map, and this one is for 3ds Max users. Okay, so we have 3ds Max, the same thing. We have files coming in to 3ds Max. We have the JPEG, PNG, EXR files 1. Baked maps, usually TIFF, equal to 1. Basically, you're going to override those values. You can write that using the material editor. Basically in the material editor, you just go ahead and override the value. I'm going to show you this later on in this thread actually, when I talk about the gamma setup in 3ds Max in V-Ray. And after that, you get two choices, as we said before, for the web, and this is actually a mistake, so it's 2.2. I'm going to change it. Or you go to Nuke, and from Nuke, then you go ahead and export for the web. So you've done your compositing here in Nuke and you export. I think it's really, really clear now. So now, let me see. I don't want to forget anything. Okay. Well, this is, yeah, okay. I talked about that. Okay, working in floating points. Okay. But in conclusion, to sum up, keep in mind compositing, which is the core technique used at CG Alter, should only be done in full float linear space. Last but not least, as visualizers, always refer to photography while producing 3D visualization. And yes, this is really, really important. Take your time. Take your time to digest this process in your mind. It's okay. It takes time. It really takes time. It took me, 4 months to really get used to this process. So really, take the time to study all of those kind of ideas here. And if you have any questions, please just comment here, or subscribe to get notified when a new article is released, or a new training, or a new video tutorial. Okay, at the end, just if you have any question, please email me or add them here in the comment. And I hope you find this video useful. All right, with Husmal, Thank you so much.